is we have a curve. There is a bell curve, a T-curve, technically. And that curve has an average. And for our data right now, we're assuming it's 3 inches. We're assuming the null hypothesis is 3 inches, which we're going to normalize down to 0. We're going to put that on a normalized curve with 0 in the middle. Now it looks like to me that our x bar is down here somewhere. Right? Our x bar is somewhere down here. The problem is, we could run those numbers through 1-bar stats and figure out what the average is. Has anybody done it yet? Gotten the average of those 6 or 7 numbers? It's okay if you had it. Even if you had it, where would I draw it? Right? Where would I draw it? Would I draw it here? Would I draw it here? Would I draw it here? I mean, it's hard to know because not only would I have to have x bar, what else would I have to have? You know, you said it a few times today, actually. You've forgotten it already, and that's okay. What should always go with an average? To tell you how extreme the average is.
Margin of error?
Yes! Yeah, there has to be a plus or minus on that average to know where it's going to be compared to this 3. Suppose, for example, make up a number. Make up a number. 7. Except we underestimated. How about we call it 0.7? Is that okay? 0.7. Suppose our average... Well, that's not even realistic. Let's say our average is 2. That makes more sense. Jesus. Let's say our average is 2. Where would 2 go? Would it go here? Would it go here? We know it wouldn't go here. It's left of 3. But where would it go? Well, it depends on how stretched this curve is. And what measures the stretch of a curve? How wide or how narrow a curve is. What changes that?
Margin of error?
Exactly. So you have to not only know the average, but the standard deviation that goes with that average. And here's where the whole thing comes together for a t-test. When you look at the test statistic for a t-test, it's going to look like this. You know the sample average because we're going to call it x bar. You know that already. You know the population average because we were measuring against mu, which is 3. You might not remember this, and it's okay if you don't because I'm not going to test you on this. But the standard error is that guy from the central limit theorem. Remember him from back in the day? You take your standard deviation and divide by the square root of n. You can say no, you don't remember this. It's like 6 months ago. That's totally fine if you don't remember it. But you divide by the square root of the sample size because that's what controls the stretchiness of that sampling distribution. And that's what tells us how far down from 3 our average actually is. It might be right next to 3 because our sample size is so small. It might be way the hell far away from 3 if we guesstimate it so low that it's ridiculous. All right? But it's all a question right now. And that's not it. Even after we calculate, this is why t-tests are a pain in the ass to run by hand. Even after you calculate this, the curve changes. You've totally forgotten this, I'm sure. But in week 3, we talked about the Guinness Brewery. You might remember that. Why did we talk about the Guinness Brewery? Because we're in Bend, right? Talk about beer.
He invented the T.
Thank you! Because Gossett, thank you, Chris. Gossett invented the t-distribution. And he invented the t-distribution to deal with small sample sizes. And remember what happened as the sample sizes changed? The curve changed. So not only do you have to have this, but you have to know which curve you're on. I say to hell with all of that. Let the technology do it for you. Yes? Is that okay with you guys? Yeah, I think so. I mean, it's too much. It becomes, we're focusing on the wrong thing if we focus on the math. I want to focus on the interpretation of what's going on, not the math itself. So I hope that's fair. Okay, good. All right. Let's go to the technology. Let's get 7 and 8, the test statistic and the p-value. All right. We'll see if my type 2 error worry is justified or completely full of crap.